accustomed to thinking that true technology is the invention of the 20th century. Computers, airplanes, robots. But what if I told you that people living in the dark and seemingly backward Middle Ages were much closer to our modern achievements than you might think? They almost invented the steam engine, created mechanisms that would become the basis for modern watches, and developed medical instruments that are still in use today. They didn't just survive, they built, invented, and improved, using only their hands and natural materials. It was an era when the human mind worked without modern conveniences, and every new discovery was the result of long observation and painstaking work. Medieval craftsmen did not know the laws of physics as we understand them today, but they intuitively applied them, creating amazing mechanisms that became the harbingers of our technological era. Their desire to make work easier, improve the quality of life, and understand the world around them led to discoveries that changed history. Watch the video to the end, and you will learn why people who lived 1,000 years ago were so close to creating modern technologies that their developments still inspire admiration and amazement today. When we look at modern clocks, we think they are the pinnacle of engineering, the result of centuries of scientific and technological development. In fact, their history began not in the 20th century, but in the Middle Ages, an era when craftsmen were obsessed with one idea that seems simple at first glance: to learn how to measure time accurately without relying on the unreliable sun or flowing sand. This was not just a whim, but an acute practical necessity. Churches needed a precise schedule of prayers, which allowed them to adhere to a strict daily routine. Merchants and craftsmen needed precision to organize their work, conclude deals, and meet deadlines. It was this desire for order and control over time that led to the emergence of the first prototypes of modern chronometers. At first, craftsmen used water clocks, known since ancient times, but they significantly improved them. While ancient devices worked on the simple principle of water flowing from one vessel to another, medieval craftsmen added complex mechanisms to them: gears, floats, and levers. Some of these systems could even make a sound to mark each hour, which was an incredible achievement for that time. Such clocks were much more complex than a simple scale carved in stone and required a deep understanding of mechanics and hydraulics. One such mechanism, for example, could ring a bell to alert monks to prayer time, which was critical to the life of monasteries. But the real revolution began when craftsmen started thinking about how to get rid of water, which froze in winter and evaporated in summer, making water clocks unreliable. This is how the idea of mechanical clocks was born. They replaced flowing water with a falling weight, which, under the influence of gravity, set in motion a complex system of gears. The earliest mechanical clocks were huge. They weighed several tons and were installed on city towers, becoming the center of public life. Their gears were forged by hand, each detail carefully fitted by master blacksmiths and watchmakers. Such clocks not only showed the time, but could also set in motion complex astronomical models, show the phases of the moon, the position of the sun, and even the movement of the planets. These huge tower clocks incorporated all the basic principles used in modern mechanical devices. They had gears to transmit motion, a pendulum to ensure uniformity, a release mechanism to regulate speed, and counterweight systems to maintain balance. As a result, it was a prototype not only for clocks, but also for any other mechanism that uses the energy of a weight or spring. Each detail was the result not of tedious mathematical calculations, but of intuition, a deep understanding of materials, and unyielding craftsmanship, which makes them even more amazing. Today, we live in a world where time is measured with millisecond precision, but this precision did not appear instantly. It was the result of centuries of humanity's obsession with the idea of accurate timekeeping. In the Middle Ages, this obsession took on special significance. Unlike ancient civilizations, which measured time conventionally by the sun or the length of shadows, The European Middle Ages brought religious and economic rigor to the process. Monasteries, with their strict schedules of prayers and liturgies, became the first customers for accurate measuring instruments. 7 and sometimes 8 times a day, monks had to gather in church, and missing even one service was considered a serious violation. This required an instrument that could work in any weather, day or night. Trade also stimulated the development of chronometers. With the increase in trade and the emergence of bills of exchange, there was a need for accurate timing. Craftsmen working on commission had to meet agreed deadlines. Even agricultural work, which depended on the season, required a more accurate calendar than observations of the sun could provide. Thus, the desire for order and predictability in everyday life prompted the geniuses of their time to search for new solutions. It was then that the first prototypes of chronometers were born, which served as the basis for future inventions. Water clocks, known since ancient times, became the starting point for medieval craftsmen. But their classic principle, the simple flow of water from one vessel to another, was too inaccurate and unreliable. First, they added a complex system of counterweights and levers that regulated water pressure, ensuring a more even flow. This was a real breakthrough, as it eliminated errors caused by changes in water volume. Then they integrated gears. These gears, driven by a float that rose and fell with the water level, in turn rotated the hands on the dial. For the first time, the movement of water was converted into the mechanical movement of the hands, which was revolutionary for its time. Moreover, the craftsmen added additional mechanisms to the water clock. Some of them could open and close figures of people or animals that acted out scenes at certain times. Others were equipped with bells that rang to mark each hour. This was much more complicated than simply carving a scale on stone. One such mechanism, for example, was installed in Strasbourg in 1354 and could ring a bell to alert townspeople and monks to prayer times. It was not just a device for measuring time, but a symbol of the city's prestige and technical progress. However, water clocks had one significant drawback. They were useless in winter when the water froze, and in hot weather when the water evaporated. Craftsmen realized that they needed a new operating principle that would not depend on climatic conditions. They replaced flowing water with a falling weight, which under the influence of gravity set in motion a complex system of gears. To prevent this movement from being instantaneous and chaotic, a release mechanism was invented, a brilliant invention that became the heart of all mechanical clocks. This mechanism consisted of a system of an anchor and an anchor wheel, which alternately blocked and released the movement of the gears. This allowed the weight to descend not immediately, but at a certain, strictly calibrated speed, which ensured accuracy and made the clock truly reliable. The earliest mechanical clocks were huge. They weighed several tons and were installed on city towers, becoming the center of public life. Their gears were forged by hand, each detail carefully fitted by master blacksmiths and watchmakers. Such clocks not only showed the time, but could also set in motion complex astronomical models, show the phases of the moon, the position of the sun, and even the movement of the planets. They were not just devices, but symbols of progress, and their creators were considered true geniuses and received enormous respect in society. This painstaking work, which took several centuries, led to the creation of a device that changed human life forever. Clocks allowed people to plan their lives, organize their work, and synchronize their actions. It was the beginning of the era of accurate time. Ultimately, medieval craftsmen gave us more than just a clock. They gave us the ability to manage time. With their help, humanity began its journey toward precision, order, and predictability. It is from this moment that we can speak of the birth of a scientific approach to the world. Share in the comments which medieval invention you think was the most important for the development of technology. We tend to associate steam engines with the 19th century, the Industrial Revolution, locomotives, and factories. But the idea of using steam to power mechanisms originated much earlier, in the Middle Ages. In the 15th century, Italian inventor Giovanni Fontana developed a steam rocket. It was a small wooden model, hollow inside, which worked on the principle of jet propulsion. Water was poured into it and then heated. The water turned into steam, which, escaping through the nozzles, propelled the rocket forward, demonstrating the potential of a new force. This principle seemed to be just a fun toy or a demonstration device, but it proved that steam could be used to create directed thrust, which was a revolutionary idea at the time. In the same century, Leonardo da Vinci left drawings in his notes that are now referred to as the prototype of a steam cannon. He proposed using the power of steam to propel shells out of the barrel at tremendous speed, creating a weapon of incredible power. His ideas, like many others, were not realized during his lifetime, but they show that the concept of using steam as a driving force was in the air. Da Vinci was not just an artist, but a genius engineer who saw potential in a force that many considered to be merely a side effect of boiling water, capable only of lifting the lid of a kettle. Medieval alchemists, in their attempts to turn base metals into gold, often experimented with heating liquids in sealed vessels. They noticed that when heated, the vessel swelled, and the steam, escaping outward, had enormous force capable of destroying the vessel or blowing off the lid if the pressure was not calculated correctly. These observations, which were only a side effect for them, could have led to the creation of the steam engine if the alchemists had had more specific goals than the philosopher's stone. But unlike engineers, they did not seek practical applications for their discoveries, seeing them only as magical or philosophical symbols. In the 17th century, French inventor Denis Papin created a steam engine that was the direct predecessor of steam engines. It worked by heating water in a cylinder, where the steam pushed the piston upward. Then as the steam cooled, a vacuum was created inside the cylinder, which pulled the piston back, creating a repetitive mechanical motion. Papin did not invent the steam engine in its modern form, but his work showed that steam could be used to create mechanical motion, which could then be transferred to other mechanisms. If Denis Papin and other medieval inventors had received enough support, we might have seen the Industrial Revolution several centuries earlier, but their ideas remained in the shadows because there was not enough material, funding, and, most importantly, understanding to implement them. They were ahead of their time, and their discoveries remained unclaimed until economic and social conditions became favorable, and society was ready to accept such radical changes. It was during this era, when steam engines were nothing more than toys or ideas on paper, that the foundations for the future were laid. Without these first steps, albeit uncertain, humanity would never have come to create the powerful locomotives, steamships, and factories that changed the world. It was a time when brilliant intuition was ahead of available technology, and engineers instinctively knew where to go next. Many of these inventors worked alone, without the support of the state or large corporations. Their discoveries were the result of personal passion and curiosity. They did not have access to modern materials such as cast iron or high-quality steel, which made their projects extremely difficult to implement. Often their ideas were ridiculed by their contemporaries or considered mere eccentricities.
How the mechanism works.
In addition to Denis Papin, there were other, lesser-known inventors who also experimented with steam. One of them was Jerome Cardano, a 16th century Italian mathematician and engineer who described a primitive steam mechanism in his writings. He proposed using steam to push water out of a container, thus creating a pump. His idea did not gain widespread acceptance, but it shows that the concept of steam as a driving force was in the minds of many prominent people of that era. These thinkers were very close to starting the Industrial Revolution. Watch the video to the end to find out what prevented them from making this breakthrough. When we talk about the Middle Ages, images of primitive and cruel medicine often come to mind. But behind the facade of superstition and mysticism lay brilliant discoveries that formed the basis of modern medicine.
What if it doesn't work?
Medieval doctors and apothecaries were not just healers, but researchers who intuitively moved in the right direction. They sought to understand the human body and find ways to alleviate suffering using all the methods and materials available to them. Medieval surgeons, for example, were much bolder and more skilled than is commonly believed. They successfully performed limb amputations, removed stones from the kidneys and bladder, and operated on cataracts. Of course, all this was done without anesthesia and antiseptics as we understand them today, but their skills were remarkable. They used special instruments that were very similar to modern scalpels, tweezers, and clamps, handmade from iron and bronze. While in Europe, medicine often went hand in hand with religious beliefs, in the Arab world and Byzantium, it flourished as a separate science. The eminent Persian scholar Ibn Sina, known in the West as Avicenna, wrote the Canon of Medicine, which was the standard reference book for doctors until the 17th century. In it, he systematized knowledge about the symptoms of diseases, proposed methods of treatment, and even introduced the idea of isolating patients to avoid their contact with others. It was a prototype of what we now call epidemiology and the principles of disease control. Medieval apothecaries did not just prepare herbal decoctions. They conducted complex experiments on the processing and combination of plants to find the most effective medicines. Many of the plants they used are still used in pharmacology today and form the basis for a variety of drugs. For example, digitalis, which was used to treat heart disease, is now the basis for heart medications. Willow bark, which was used as a pain reliever, contains salicylic acid, the basis for modern aspirin. Anatomical knowledge was also at a high level, although it was mainly obtained illegally through the dissection of bodies, which was considered unacceptable from the point of view of many social norms. Nevertheless, in the 14th century, public anatomical dissections were performed at the University of Bologna to better understand the structure of the human body and internal organs. This knowledge, albeit obtained in secret, allowed surgeons to perform more accurate and successful operations, avoiding vital organs and blood vessels. They strove for precision and accuracy, understanding that every mistake could lead to undesirable consequences. The first hospitals appeared during this period. Of course, they were not like modern hospitals, but it was in them that the idea of inpatient treatment was born. These were places where patients were cared for, provided with food and rest, which in itself contributed to their recovery. Conditions in such hospitals were often much cleaner and more orderly than in the homes of the poor. Thus, these institutions were the prototypes of our modern clinics, where treatment is carried out in specially designated places. Medicine in the Middle Ages was not just witchcraft, but a developing science. And although it was limited by superstitions, medieval doctors and surgeons were very close to revolutionizing medicine. They created instruments, wrote treatises, passed on knowledge and accumulated experience that became the foundation for future generations of scientists. Their tireless pursuit of knowledge, even under severe restrictions, was the driving force behind progress. They developed sophisticated instruments that can be seen in museums today and are remarkable for their elegance and functionality. Surgical kits included everything from forceps for removing fragments to fine needles for suturing. These instruments, forged by master armorers, were durable and precise, allowing even the most complex procedures to be performed. Their design was so well thought out that some modern instruments have a similar shape and purpose. In addition to official medicine, there was also folk medicine, which was based on thousands of years of experience. Healers and herbalists passed on their knowledge by word of mouth. They used local plants, roots, minerals, and even honey to make medicines. Their knowledge was very valuable, and much of it was later incorporated into official medicine. Many medieval doctors believed in the power of astrology. They believed that the movement of the planets and stars affected human health. Therefore, before beginning treatment, they always looked at the stars. This practice, which seems absurd to us today, was part of their scientific approach. In cities where large cathedrals and castles were built, there were also medical facilities. They were intended for workers who were injured during construction. These facilities provided first aid. They were the precursors to modern emergency rooms. Medieval doctors also understood the importance of cleanliness. They recommended that patients wash their hands and bodies frequently, which seems obvious to us today, but was revolutionary advice at the time. They also knew the importance of fresh air and healthy food. Medicine in the Middle Ages was very progressive for its time. Its development was driven by necessity. The growth of cities, trade, and wars all created new challenges that the doctors and engineers of the time successfully tackled. They were very close to achieving a true scientific revolution. But medieval medicine was also cruel. There was no anesthesia, and operations were performed using brute force. Nevertheless, doctors tried to ease the suffering of their patients by giving them opium and other herbs to reduce pain. This was a real breakthrough for its time. They did not know about germs, but intuitively understood that cleanliness helped to avoid infections. They used clean bandages and tried to disinfect instruments over a fire, which was the right decision. Medical schools at that time produced doctors who had a deep knowledge of the human body. They knew about the structure of bones, muscles, and internal organs. They knew how the body's systems functioned. Their knowledge was not as complete as that of modern doctors, but it was deep enough to save lives. They were very close to bringing about a real revolution in medicine. The printing press, which seems like a common device to us today, was one of the most revolutionary inventions of the Middle Ages. It changed the world of information by making knowledge accessible to everyone. It was the prototype not only of typography, but also of the entire information society in which we live today, where every idea can be instantly replicated and made available to millions. Before Johann Gutenberg invented the printing press in the 15th century, all books were copied by hand. It was an incredibly expensive and labor-intensive process, requiring many months of painstaking work by experienced copyists. For example, it could take years to create a single Bible, and its price was comparable to the cost of an entire castle or estate. As a result, books were only available to a very narrow circle of the elite, monks and wealthy aristocrats. Gutenberg's idea was ingeniously simple. Instead of carving an entire page out of a wooden board, as was done previously in China and Korea, he invented movable type. These were individual metal letters cast with high precision, which could be assembled into words, lines, and entire pages. After printing was complete, the letters were disassembled and could be used to typeset new text. This technology was much faster and more efficient than any previous methods. The advent of the printing press dramatically reduced the cost of books and made them accessible to the general population. Now anyone who could read could afford to buy not only a book, but also a brochure, leaflet, or newspaper. Information that had previously been passed on by word of mouth and often distorted could now be disseminated at lightning speed without alteration. This marked the beginning of the era of mass communication. This had enormous consequences for society as a whole. Newspapers appeared with news that reached people in the most remote corners of the country. Scientific treatises, which had previously been kept in single copies, were now printed in thousands of copies, allowing scientists to exchange knowledge and accelerate progress. This led to an increase in literacy and ultimately to the Protestant Reformation, as people could read the Bible for themselves without the mediation of the Church, which became one of the main catalysts of this movement. The printing press became not just a device for printing books, but a machine for spreading ideas. It gave people the opportunity to learn, exchange thoughts, and critically evaluate the world around them. This machine was the prototype not only for the printer, but also for everything we see today in the form of blogs, news sites, and social networks. It turned information into a weapon, a commodity, and the main value of the new era. The invention of movable type was just one of Gutenberg's ingenious solutions. Equally important was the creation of an alloy for these letters, soft enough to be easily cast, yet hard enough to withstand pressure. He also developed a special ink that adhered well to metal, as well as the printing press itself. All these elements worked together as a coordinated system. This machine gave impetus to the development of science, education, and culture. For the first time, it became possible to standardize knowledge by creating uniform textbooks and reference books. Maps printed on the machine became more accurate and accessible, which accelerated the age of discovery. Poetry and prose written by talented authors could now be read by tens of thousands of people, not just hundreds. What do you think was the most important thing about the invention of the printing press? Speed, accessibility, or the ability to spread ideas? Today, glasses, microscopes, and telescopes seem ordinary to us. But all this became possible thanks to discoveries made in the Middle Ages. It was then that people began to understand how lenses could be used to improve vision and see what was invisible to the naked eye. This era became crucial for the emergence of optical science. The first eyeglasses appeared in Italy in the 13th century. They were simply two lenses joined together and held on the nose. They were intended for monk scribes who were losing their eyesight from long hours of working with small, dimly lit texts. The invention of glasses was a real revolution. It allowed people with impaired vision to continue working and reading. This significantly prolonged the active life of craftsmen, scientists, and writers. Master opticians who learned how to grind lenses soon realized that they could be used for more than just vision correction. They began experimenting with combining lenses, which led to the creation of prototypes for microscopes and telescopes. Of course, these were not the sophisticated devices we see today, but they worked on the same principles. These experiments became the basis for future optical devices. In his works, the English philosopher and scientist Roger Bacon described as early as the 13th century how lenses could be used to see stars and examine very small objects. He even talked about the possibility of creating a device that would bring distant objects closer. He did not create the telescope himself, but his ideas anticipated discoveries made several centuries later. Medieval master opticians were true geniuses. They learned to grind lenses to perfection in order to magnify or reduce images as much as possible. It was very painstaking work that required enormous patience and skill. Many of these masters were monks who worked in monastery workshops. Their work not only improved vision, but also opened up new horizons for science. These discoveries allowed astronomers to see stars and planets, and biologists to study microorganisms. These craftsmen laid the foundation for the development of optics, which today is the basis for many modern technologies. Medieval achievements in optics were not just accidental discoveries, but the result of a deep, albeit intuitive, understanding of physical principles. The craftsmen of that time faced a problem that needed to be solved and found the answer by working with the materials available to them. They used quartz crystals and glass, which had to be ground by hand, requiring incredible precision. Every millimeter of the lens surface had to be perfectly smooth so as not to distort the image. This art was honed over many years, passed down from master to apprentice. The further development of optical devices became inevitable. Craftsmen began to experiment with combinations of lenses. By combining lenses of different shapes and curvatures, they discovered that they could not only correct vision, but also magnify images. This led to the creation of the simplest magnifying glasses, which then turned into primitive microscopes. These devices made it possible to examine the structure of tissue, insects, and other small objects, which was impossible before. This opened up new horizons for research in biology and anatomy. They gave humanity the opportunity to see what had been hidden from their eyes, from microscopic organisms to distant stars. This opportunity changed everything, from medicine to astronomy. Their work proved that even with limited resources and knowledge, humans can make great discoveries.
Stay clear of those sections.
The Middle Ages were an era of war, which stimulated the development of military technology. Of course, these were not tanks and airplanes, but their military machines were so sophisticated that many of them were used until the 19th century. They were very close to creating weapons of mass destruction. One of the most powerful inventions was the catapult. It had been known since ancient times, but medieval engineers significantly improved it. They increased its size, strengthened its construction, and made it more accurate. A single catapult could hurl huge stones capable of breaking through castle walls. And although it was a weapon that did not always hit its target, its power was enormous. But the main revolution was the advent of gunpowder. It was invented in China, but it was in the Middle Ages that it began to be used for military purposes. At first, it was used as an explosive to blow up walls. Then the first cannons appeared, primitive, clumsy, but incredibly powerful. They could fire cannonballs that pierced castle walls and knight armor. And although the cannons were very primitive, their appearance changed everything. Now there was no need for lengthy sieges and assaults that lasted for months and claimed the lives of thousands of soldiers. One cannon could decide the outcome of a battle. This led to knightly castles and heavy armor gradually becoming a thing of the past. But medieval craftsmen did not only create weapons of destruction, they also developed protective equipment. Heavy armor became a true work of art. It was made of many plates connected to each other, which allowed the knight to move freely and at the same time be protected from blows. Armor was the prototype of modern armor, and its creators were true masters of their craft. What do you think was the most important thing about the advent of gunpowder? Its destructive power, or the fact that it changed the very nature of warfare? We are accustomed to thinking that the true era of great geographical discoveries began in the 15th century, but its precursor was the development of shipbuilding in the Middle Ages. Ships ceased to be simple boats and turned into real floating fortresses capable of withstanding storms and long voyages. Medieval craftsmen improved the design of sailing ships. They made them stronger, more stable, and more maneuverable. This allowed them not only to sail along the coast, but also to venture out into the open sea. This was the beginning of the era of long voyages. Navigational instruments were also developed. The compass, known since ancient times, was improved and became a reliable assistant on long voyages. The astrolabe, which was used to determine latitude by the stars, was invented in the Arab world. But it was in the Middle Ages that it became an indispensable tool for European navigators. The advent of heavy merchant ships changed the economy. It was now possible to transport large quantities of goods over long distances. This led to the growth of cities, the development of trade, and the emergence of new trade routes. The medieval craftsmen who built these ships were true geniuses. They did not know about hydrodynamics and water resistance, but they intuitively understood how to make a ship stable and fast. They used their knowledge of wood, wind, and currents to create ships that became the basis for future discoveries.
Just the keel.
Yes, it lists slightly to port.
Agriculture in the Middle Ages seems primitive to us, but it was during this era that inventions were made that increased crop yields and made it possible to feed a growing population. They were not as spectacular as cannons or clocks, but their contribution to the development of civilization was enormous. One of the most important inventions was the heavy plow. Before its appearance, light wooden plows were used, which only scratched the ground. The heavy plow with an iron plowshare plowed the soil deeply, which significantly increased crop yields. This plow, which was driven by horses or oxen, made it possible to cultivate huge areas of land. Another important invention was the three-field system of agriculture. Before that, a two-field system was used, where half of the field was sown and half was left fallow so that the soil could recover. The three-field system allowed 2/3 of the field to be sown, leaving only 1/3 fallow. This significantly increased the amount of harvest and made it possible to feed more people. Another important achievement was the development of watermills. They not only ground grain, but were also used for other purposes, for sawing wood and processing leather. This was the prototype of future factories. The mills operated without human labor, which freed people up for other tasks. All these inventions were not just accidental discoveries. They were the result of long observation and painstaking work. Medieval peasants and craftsmen were very close to bringing about a real agricultural revolution. When we see medieval castles and cathedrals, we think they are just beautiful architecture. But in fact, they were true masterpieces of engineering that became the prototypes for modern buildings. Medieval architects were very close to creating modern skyscrapers and bridges. One of the most important achievements was the invention of scaffolding. Before that, builders used primitive supports that were not reliable. Scaffolding made it possible to erect buildings of any height. This was the beginning of the era of high-rise construction. Another important invention was arched and domed structures. Medieval architects figured out how to use arches to evenly distribute the weight of a building. This let them create huge spaces without columns or supports. And dome structures made it possible to build huge roofs without using extra supports. This was the prototype for modern stadiums and halls. Another important achievement was the invention of cement. Of course, it was not modern cement, but its medieval counterparts were very similar to it. This made it possible to build stronger and more stable buildings. Medieval architects also experimented with water supply systems. They built canals and aqueducts to deliver water to cities and castles. This was the prototype for modern water supply and sewage systems. Mining in the Middle Ages was very dangerous and difficult. People extracted metals and coal using primitive tools in their hands, but it was during this era that inventions were made that became the precursors to modern mining methods. They were very close to creating explosives. Another important invention was the cargo lifting system. Miners used winches and cranes to lift ore and coal to the surface. These systems were the prototype for modern cranes and elevators. The invention of the mine drainage system was also an important achievement. Miners faced the problem of flooding in mines. They invented pump systems that pumped water out of the mines. This was the prototype of modern drainage systems. All these inventions were not just accidental discoveries. They were the result of long observations and painstaking work. Medieval miners and engineers were very close to making a real technical revolution. They did not know the laws of physics, but intuitively applied them, creating amazing mechanisms that became the harbingers of our technological era. We conclude our journey into the world of medieval technology. Today we learn that people in the Middle Ages were much closer to our modern achievements than is commonly believed. They almost invented the steam engine, created mechanisms that became the basis for modern watches, and developed medical instruments that are still in use today. Their desire to make work easier, improve the quality of life, and understand the world around them led to discoveries that changed history. These craftsmen were true geniuses of their time. They did not know the laws of physics, but they intuitively applied them. Our story shows that technology is not just about chips and electronics, but also about the human mind itself, which strives to overcome difficulties and make life better. Medieval craftsmen were true pioneers who paved the way for our technological era. Which of these facts about medieval inventions surprised you the most? And what other medieval discoveries do you think could have changed the world? Share your thoughts in the comments, and don't forget to subscribe to our channel to learn more about the most interesting mysteries of the past.